Hello, Math 151. And here we are with our first video lecture. And we're going to be talking about systems of linear equations in two variables. And that just means we're going to be solving some linear equations and where they intersect. So let's just pull up a graph over here and stick on something you're familiar with. Then that's just a regular old linear equation. And we've solved for stuff like this before, like the y-intercept or the x-intercept, and maybe the slope. But what we're going to do is stick another linear function onto this. And our interest is going to be now where they intersect. And that's what this section is going to be about. How do we find this intersection? And we're going to talk about two ways to do that. And the first one is substitution. And substitution is usually the most straightforward one. And that just simply means we're going to solve for one of the letters and then stick that into the other equation. So if we look at this first problem here, hopefully you can see they're both solved for y. So solved means like y equals or x equals. And so we can take either one and stick it into the other. So for instance, maybe we want to take this y equals x plus 5, and we're going to stick it into the top equation here. So if we do that, so instead of instead of y, we're going to stick in x plus 5. And so we substituted the bottom equation into the top one. And now we're in a position where we can just simply solve this. So for instance, maybe we'll subtract 2 from both sides. So 5 minus 2 will get us a 3 here. And then maybe we'll subtract x from both sides. So if we subtract x from both sides, that'll make this a minus 4 over here. Oops. And then finally, to solve for x, we would divide everything then by minus 4. To get our answer for x. Now for these problems, MyMathLab is going to want the ordered pair, so the exact location on the graph, which means once we have x, we have to plug this back into one of the other equations. Now it doesn't matter which. We can plug it into either equation. I usually like choosing the simpler looking one, which looks like this y equals x plus 5. So instead of x, we're going to now have our minus 3/4. We'll stick that in there. And we'll need to get a common denominator here of 4 to solve this. So 4 times 5 is 20. This will be 20 over 4. And now we can add that together to get our final answer of 17/4. And the answer that MyMathLab is going to prefer is to then put this in ordered pair notation. So using a parentheses, our x value here was minus 3/4. And then comma, our y value, which is 17/4. And this is then our final answer. This would be where they intersect then on the graph. So x is about it is minus 3/4, and then y is 17/4. Let's check out another one. So again, here's two linear functions, and we're interested in where they intersect. So it looks like about the origin, but we do want to solve this algebraically to get the exact answer. So we have these two equations, and the first thing we want to do is solve one of them for one of the letters. And I want to stress it doesn't matter which. You can solve for whatever you want and plug that into the other equation, and it'll always work out, as long as you're doing the math correctly, of course. I usually like to choose the one that looks simpler. So this bottom equation looks like it's the simplest to solve because we just have to put 3y on the right side. So we would get then at x equals 3y. And then we can take this equation and stick it into the top one. So instead of x, we're now going to have 3y. And then here's our new equation we'd have to solve. And of course, 5 times 3 is 15. And then 15y plus 2y is 17y. And then to finally solve for y, divide both sides by 17. And then we get our answer that y equals 0. And once we have solved for one of the letters, we do want to solve for the other so we can write our ordered pair answer. So we'll take this and simply plug it in to one of the other equations. It doesn't matter which. So for instance, maybe we'll plug it in this top one. So now we have y equals 0. That's what we solved for. So right here, instead of y, we know that this is now 0. And of course, 2 times 0 is 0. Divide both sides by 5, and we have our answer for x. So indeed, these do intersect at the origin. And to write our final answer, we would put that in ordered pair notation. And so we have our final answer of 0, 0. And a nice thing you can do if you wanted is our solution should work in both equations. So for instance, if we plug 0, 0 into the top equation, we'll get 0 equals 0, which is a true statement, which means our solution works. As well as if we put it into the bottom equation, we'll also get 0 equals 0, which tells us then that this works. So all of these problems, you can check your answer. So let's check out another one. So looking to the right, 2 more linear equations. Our goal here is to find out where they intersect. Now in this case, none of the equations are solved for x or y. And again, it's up to you on what you want to solve for. I personally choose what looks simpler. So this bottom one looks to me the simpler one to solve, because all we have to do is subtract 11 from both sides and then add y to both sides. And now that we've solved one of the equations for one of the letters, we can just stick that into the other equation. Now it is important that you do stick it into the other equation to get an answer. If you stick the equation back into itself, all it's going to tell you is that it's a true statement. It's going to be like 0 equals 0 or 2 equals 2. Just going to tell you it's a true statement. It's not going to give you a solution. So we do have to plug this into the other equation we haven't used yet, which is the top one. So now, instead of y, we're going to have our expression of 3x minus 11. So we're going to substitute this equation into y. Now this does have 2 terms, so we have to be careful with distribution, which means use parentheses. We'll have 3x minus 11 in there. So we substituted one equation into the other. And once we've done that substitution, we will solve it. So the first thing we'd have to do here is distribute. So 5 times 3, we're going to say 15x. And then a 5 times the minus 11, we're going to say minus 55. And I'm just going to get that out of the parentheses now since we don't need the parentheses anymore. We'll gather like terms. So 2x plus 15x is 17x. And then we'll add 55 to both sides. So on the right side, we'd have 55 minus 4 to get us a 51. And then finally, we would divide both sides by 17. And 51 divided by 17 is 3. And so we got an answer for one of our letters. And once we have an answer for one of the letters, we can plug it back into either of the equations. It isn't going to matter. Since we've already solved this one for y, this would be the easier one to choose since it's already solved for y. And we just got to stick now x equals 3 into it. So now here, x equals 3. And 3 times 3 is 9. And then 9 minus 11 would give us a minus 2. And so we have our answer for x, we have our answer for y, and then we will finally put this in then ordered pair notation for our final answer. So x is 3 and y is minus 2. And again, you can take this result and it has to satisfy both of our equations. So it's a way for you to check your answer. So let's check out another one. Looking to the right here, go to another example. And this one looks a little bit more complicated, but it's actually just a few extra steps we have to do. So again, the goal here is to solve for the intersection of where these two cross each other. And the first thing we're going to want to do with this, because this one's a little bit messier, is we're going to want to combine these terms to clean this up a little bit. In other words, we want to simplify these equations that they're giving us. So if we look at this, there's a minus 2x on the right side. So if we add 2x to both sides, we can get rid of that. And then adding 2x to both sides will get us a 4x then on the other side. So this equation here is the same as where we started. It's just been simplified. It's like saying 2/4 equals a half. It's the same number. It's just been simplified. So we'll do that again with the second equation they're giving us. So if we look at this, we could subtract x from both sides. So if we do that, we'll get rid of the x on the right side. And then 3 minus an x will get us a 2x there. And we can also subtract 3y from both sides. So if we subtract 3y from both sides, it's gone on the right side. And then 4 minus 3, we get us a 1. So the two equations they gave us can simplify then into these two. So now we can go back to our substitution. So this, yes, these equations are a little bit more complicated, but it's just a matter of simplifying them. And now we can go into substitution. Again, you can solve for whatever letter from whatever equation you want. I myself usually try to choose the one that looks simplest. So that to me would be this bottom one. So to solve for y, all we have to do is get the 2x to the right side to get us a minus 2x. And now that we have solved for y, and this came from the second equation, we do have to plug this then into the other one, the first equation. So our first equation here, instead of y, we're now going to have the result of 14 minus 2x. There are two terms here, so we have to be a little bit careful with distribution and use a parentheses. We'd have 14 minus 2x for y. And so here's our equation to solve. And the first thing we're going to need to do here is some distribution. So we'd have minus 3 times 14. So this would get us a minus 42. And then minus 3 times minus 2 will get us a positive 6. And we don't need that parentheses anymore since we distributed that factor. So I'll just get rid of it. And plus minus is a minus. And then we'll gather like terms. So we'd have a 4x and a 6x, which is 10x. And then we'll add 42 to both sides. So we'll get a 50 then on the right side. And then divide both sides by 10. And so we have our answer for x, that it equals 5. And now once we have an answer, we do have to get the other letter answer. So we'll take this x equals 5, plug it into one of the equations. It doesn't matter which. So say this one here. So instead of x, we know x is 5. And so we'll plug that in. Of course, 2 times 5 is 10. And then 14 minus 10 is 4. So we have our x answer, we have our y answer, and then the preferred way to write this is in ordered pair notation. And so we have x is 5 and y is 4. And that's our answer. And again, this is something you can check by plugging it back into our equations that we started with. So another thing the book tries to do to make these slightly more complicated looking is, of course, to give some fractions. It does make it more complicated looking. Now in this case, however, these are both already solved for y. We actually don't have to do any solving step here. We can just take one and plug it into the other. So it doesn't matter which, but I'm going to take the bottom one and I'll plug it into the top one. So here's our top equation here, but instead of y, we'll now have our substitution, which is 3/4 x plus 7. So just substituting the bottom into the top. Now, if you recall, the easiest way to deal with fractions is to multiply everything by a common denominator. So if we look at the common denominator here, we have a 4 and a 2. The common denominator here is 4. And so we'll multiply everything by 4. And this will get rid of the fractions. So for instance, 3/4 times 4 is 3. 7 times 4 is 28. Minus 1/2 times 4 is 2. And 2 times 4 is 8. And so here's our simpler equation to solve by getting rid of the fractions. And now we can go about and gather like terms. So let's add 2x to both sides. We'll have 5x on the left. And then subtract 28 from both sides. So we'd have on the right side we'd have a minus 28 plus 8 to get us a minus 20. And then to solve for x, we'll just divide both sides by 5. So minus 20 divided by 5 then would give us a minus 4. And then once we have a solution for one of our letters, we'll just plug it into one of the other equations. Again, it doesn't matter which. It'll all work out in the end if you're doing the math correctly. So instead of x, we now have our minus 4. And then we'll simply solve that for y. So 4 divided by 4 is a 1, and this will be a minus here, so this is ultimately a minus 3. And then minus 3 plus 7 gives us a 4. And now that we have x and y, we'll write it in our preferred answer, the one my math lab's certainly going to want, the ordered pair notation. So x is minus 4 and y is 4. And that's our answer. And again, this is something you can always check by plugging it back into the equations. Or as another way of having confidence, you could also look at the graph and see where the intersection is. And that does look to be at minus 4, positive 4. And if you are interested in making some nice graphs here, just to give you some confidence that your answer is looking correct, the program I'm using here on the right is actually something free I found on the internet that works really nice, and it's www.desmos.com. And if you just go to that link, there'll be a big tab right in front of your face that says Start Graphing. And just click that, and you'll go right into the graphs you're seeing on the right here. And you can just type your equations in, and it'll graph it all out. Very nice, simple program to use that's free and can give you some confidence that your answers are looking correct. So overall, substitution is actually the more powerful method, meaning that it applies to more things. The other method, elimination, is not as powerful. It doesn't apply to as many things, but its benefit is that when you can use it, it tends to be much quicker. So before I get into what it is, I kind of want to justify to you what elimination means. And by the way, the book calls this the addition method, which I have to say I've never heard it called that before. But elimination is the common name for this, and your book calls this the addition method. And what this means is that let's say we take our first equation. Again, it doesn't matter which, but let's take our first equation, and of course we can add whatever we want to both sides. So let's say that I want to add to both sides of this y. So I'm just going to add y to both sides of this. And that's something that you should be confident that you can do. You can add whatever you want to both sides. However, using the other equation, we know what y equals. Y equals x plus 5. And so we can substitute these y's with x plus 5. And what I'm going to do, though, is keep the y's on the left the same, but on the right, this y I will change to x plus 5. And this result here, actually then, we can simplify a little bit, because y plus y is 2y, and minus 3x plus x would be minus 2x, and 2 and 5 would get us a 7. And this result we got from this elimination method. And what this ultimately means, the pattern that's happening here, means that we can literally just add equations together. So if you notice these two equations right here, if we just added them vertically like this, we'd have y plus y, which is 2y. If we added minus 3x plus x, we get minus 2x. And if we add 2 and 5, we get 7. And this is the elimination method. It means that you can literally add equations together. And the goal here, though, is to add them in a way that eliminates one of the variables. So what I just did here by adding them did not eliminate a variable. We still have our y, we still have our x, and we can't solve this final equation. So we want to do elimination in a way that gets rid of one of the variables. So instead of adding these equations together, we could subtract these equations. And this is exactly like saying you're going to subtract something from both sides of the equation. So instead of adding, let's subtract these equations. So we would have y minus y, which is 0. Let me quickly insert that. So if we added these two equations together, subtract, y minus y is 0. Then we have our equal sign. And now we're subtracting. So we have minus 3x minus x, which would be minus 4x. And then we have 2 minus 5 to get us a minus 3. And so here's another equation that we can get. Again, this equation here I got from adding the equations together. And this equation I got from subtracting the equations. And subtracting ended up being the better result here, because now we have an equation that we can solve. So we can move, say, the 4x to the left side to make it positive. And then we can divide both sides by the 4 to get our answer. And we find then that x equals minus 3/4. Now I am doing the exact same problem that we did first. So we have x equals minus 3/4. And if I scroll back to our first problem again, here's the same problem again. You see that x is minus 3/4 that we got previously from substitution. And of course, once we have our x, we would have to also get the y value. So let's check out another example. On the right here, I have the second problem we did with substitution. And let's do that with elimination. You can see how that works out, and we should get the same answers. So here's our two equations together. And let me just write some stuff down here really quick. If we add these two equations together, so if we just add these together, we'd have 5x plus x to get us a 6x, a 2 minus the 3 to get us a minus 1, and of course 0 and 0 is 0. So if we just added these together, we still have an equation of two variables, and we can't solve that. So that's not something we'd want to do. Let's say, though, we decided to subtract these equations then. So if we subtracted them, we'd have 5x minus x to get us a 4x. Now we're subtracting. We have 2 minus a negative, so we're going to be adding those together to get us a 5y. And then 0 minus 0 is still 0. So now we subtracted them. And we're still in no better position here, because we still have an equation with two variables that we can't solve. So what we want to do is we want to try to make one of the variables, again, it doesn't matter which, you can choose whatever you want, but we want to make one of the variables have the same coefficient. And we can do that by multiplying both sides by something. So for instance, this equation here, if we want to get a 5x here, because the other one has a 5x, then we can simply multiply everything by 5. And again, that should be something that you're comfortable with doing. If you do the same thing to both sides, the equation still remains valid. So we'll multiply both sides by 5. So 1x times 5 is 5x. And then minus 3 times 5 would be minus 15. And 0 times 5 is 0. So all we did to the second equation was multiply it by 5. And that really helps us, because now if we look at our two equations and we subtract them, now it turns out that one of the variables will go away, and then that will allow us to solve this. So if we subtract these two equations, we'd have 5x minus 5x to get us a 0. We'd have minus 15 minus 2 to get us a minus 17. And 0 minus 0 is 0. And now we're in a position that we can solve this. Divide both sides by minus 17, and we have our solution then that y equals 0. And if we scroll back up to when we did this problem previously with substitution, our 5x, here it is again, right here. And sure enough, we got y equals 0 also with substitution. So again, if we can already get these answers with substitution, well, why do you have to do elimination? You don't necessarily have to. I mean, if you can already get an answer with substitution in the real world, that usually works out to be just fine. Again, elimination is used more for if you need something faster, if elimination will work with that. So let's check out the next problem we did with substitution. Now again, if we look at this equation, if we add them together, the x's will not cancel, and nor will the y's. So we just don't want to add them together. And subtracting the equations also will not eliminate one of the variables. So we have to multiply these equations by something so that one of the letters has the same coefficient. Now if we look at the bottom equation here, you can see, hopefully, if we just multiply this by 5, the bottom equation, then we could get a 5y there. And then we could add these equations together, and then the y would subtract out. But I also want to show you that you could also do this with x. Again, it doesn't matter which letter you want to eliminate. So instead, I'm going to do this with x. Now here we have a 2x, here we have a 3x. We want to get these coefficients to be the same, and preferably a smaller number so the numbers don't get too big. So in this case, we could both make these numbers 6. So to get this 2 to be a 6, we could multiply both sides by 3. So we'll multiply everything here by 3. So 2 times 3 is 6. 5 times 3 is 15. And minus 4 times 3 would get us a minus 12. And then I'll take the second equation. And again, the goal is to get a 6 for the x coefficient. And we can do that by multiplying everything by 2. So 2 times 3 is 6. 2 times our minus 1 here would get us a minus 2. And 2 times 11 would get us 22. And now these two equations are exactly the same as these other ones. In other words, if you graphed it, it'll look exactly the same. So the equations in blue here would be considered the simplified result. And now that we have these two equations, we can subtract them, and one of the variables will now subtract out. So if we subtract, we'd have 6 minus 6, which is 0. And here we'd have 15 minus a negative, so that'll be adding, so we'll get a 17y there. And if we subtract here, we'd have minus 12 minus 22, so that would get us then a minus 34. And now we can solve this for y. Divide both sides by 17, and so minus 34 divided by 17 is minus 2. And so we get y equals minus 2. And let's just check that back real quick to when we did this previously. Here's our 2x plus 5y equals minus 4 again. And sure enough, we got y equals minus 2. Again, we should get the same answers here. So let's check out the other problem. The next problem we did was substitution, which was this longer one where we had to combine the terms. Now again, even with elimination, the first step here would be to combine these terms up. So we already did that previously, and I'm just going to paste that result we got in there. So here are the two equations once we combined all the terms and simplified it. And if we look, the x's don't have the same coefficient, and the y's don't have the same coefficient. So in order to use elimination here, we do have to get one of the letters, again it doesn't matter which, but we have to get one of the letters to be the same coefficient. And it doesn't matter, I'm just going to choose x just to be alphabetical. And if we multiply the second equation by 2, then we can get that 2 to be a 4 like the other equation. So we'll multiply everything here by 2. So 2 times 2 gets us a 4, 2 times 1 gets us a 2, and 2 times 14 will get us a 28. And that's our second equation there. And let me just paste the first one back. So here are our two equations. Again, I know the second equation looks slightly different, but again, the graph is exactly the same as on the right. And now we can subtract these equations, and that will cause the x to be eliminated. So 4 minus 4 is 0. Minus 3 minus 2 would get us a minus 5. And then 8 minus 28 would get us a minus 20. And now we can solve this for y. Divide both sides by minus 5, and we get 4. And just double check again really fast when we did this one previously. And here it is. Our longer equation we simplified, and sure enough we got y equals 4. Now I am skipping in this elimination part that we would have to get the other variable because we want our final answer to be as an ordered pair, but we already did that previously with substitution. But again, if you do need to get, you will need to get the ordered pair. Once you have your letter from elimination, you use substitution again. It's the only way you're going to get the x value, is we're going to take y equals 4 and now substitute it into one of our equations. So again, I like to take the one that looks the simplest, so I'll take this one. And we're just going to plug in y equals 4. So instead of y, we know that now equals 4. And then we'll solve this. So we'll subtract 4 from both sides. So 14 minus 4 would be 10. And then divide both sides by 2 to get x equals 5, which is what we had previously. So elimination still has a substitution step in the end of it to get the second letter. So let's go on to the last one we did with substitution. On the right here, the one that had the fractions. Now let's check that out with elimination. Now, the fractions, of course, are always a little bit more of a pain, but these two equations are already set up for elimination because the y's have the same coefficient. So we can just subtract these two equations now, and we can eliminate the y. So y minus y is 0. And we are going to have to subtract these fractions. So let me just write this out so we can do that separately. So we'd have minus 1/2. And then we're going to subtract the other equation. So that means minus then 3/4. And then we would have 2 minus 7 to get us a minus 5. And I did forget to put the x's on those terms. There we go. So subtracting these two equations gets us this result here. And now we do have to deal with the fractions. And there's two ways you could do that. You could either get a common denominator or multiply everything by the common denominator, which I prefer to do. I think it's a little bit easier to get rid of the fractions. So the common denominator here is 4. So we'll multiply everything by 4. So 4 times 0 is still 0. 4 times 1/2 is 2. 4 times 3/4 is 3. And 4 times this 5 here will get us a 20. So there we go. Got rid of all the fractions. And now we can combine terms. Minus 2 and minus 3 will get us a minus 5. And let's add 20 to both sides. And now we can divide both sides by minus 5. So 20 divided by minus 5 will get us our minus 4. Whoops, that was my computer making that ding there. And so we got our solution then of x equals minus 4. And now to get what y is, we'd have to use one of these equations and do substitution here. So let's just take this equation, and we're going to plug in then a minus 4 here. And then we'll solve for that. So these 4's do divide out. And so this will simply be a minus 3. And then minus 3 plus 7, which should give us then a positive 4. For our final answer then, in ordered pair of a minus 4, 4. So far, all the equations we've done so far have only had one solution. I want to talk for a moment really quick about the 3 possible outcomes that can happen here with these linear equations. One possible outcome is what's been happening so far is that we get one solution. And so far, every problem we've done has been that way. Another possible outcome is that we get no solution. And then the third possible outcome is that we get infinitely many solutions. So let's check some examples of that out. And let me scroll down here to, let's use elimination on this since it'll be a little bit easier. And on the right, I'm going to scroll to what this graph looks like. And hopefully you can see by looking at this graph that these lines do not intersect. And since they don't intersect, we should get no solution when trying to solve for their intersection. So let's do that through elimination. And something else that's nice about this particular problem that I want to demonstrate with elimination is that we can add these together as it is, but it may be a little bit complicated because the x's are in a nice column order here, but then we have a 9 and 2y. And we can still do it the way it is, but sometimes people prefer to rewrite the equation so everything lines up the same. So we want to rewrite this equation so that it's x equals, which means we'll subtract 2y from both sides. And now our equation has the same column structure as the other one. Now you don't have to do this, but it makes it a little bit mentally easier in your brain, a way to order things a little bit better. And so we're going to subtract these two equations now. Because if we subtract, we'll get rid of the x, because x minus x will be 0. So let's go ahead and subtract these two equations. So x minus x would get us a 0. Then we'll have 9 minus 13 to get us a minus 4. And we'll have minus 2 minus a negative 2. So that means adding them. So we'd have minus 2 plus 2, which is 0. And then this is our final result, that 0 equals minus 4, which is a false statement. Now, a false statement in math means that the assumptions you just made are false. In other words, we assumed these lines have an intersection, and that assumption is false. These lines do not have an intersection, and so then we would say that this one has no solution. And again, this Desmos graphing tool, very easy once you graph these to see, oh, hey, there's no intersection. I should expect no solution. But it's also important to understand how the algebra looks for a no solution as well. A no solution will always result in a false statement, like 1 equals 5, or in our case, 0 equals minus 4. And that's what will happen with the algebra. You will always get a false statement, and that means no solution. So let's check out the other outcome that can happen, where we have infinitely many solutions. Now I want you to look at the graph over here on the right as I change it to this next problem. And there it is. Now if you look, I do have two equations written here, but the graph is only showing one line. And that's because these two equations are the same. So let's check out what that looks like algebraically. And again, let's do elimination on it. And let's go for the x's here. So we want the x's to have the same coefficients. So let's multiply this top equation by 3. So we'll multiply everything by 3 here. So that'll be a 3, and then a 9, and then a 6. And we're going to add that to the bottom equation. And your eyes are not deceiving yourself. These are exactly the same equations. So if we subtract these equations, what are we going to get? Well, we'll have 3 minus 3, which is 0. We'll have 9 minus 9, which is also 0. And we'll find out that this equals 6 minus 6, which is also 0. And this is a true statement. So for infinitely many solutions, this means algebraically that this will all boil down to 0 equals 0, which is a true statement. And this means that no matter what you put in for x and y, it will always be a solution. And that's ultimately because these are the same equations. They may look different, but if you look at the second equation, it's simply not simplified. If we divide everything by 3, simplifying it, we get the top equation. So the top equation is nothing more than the simplified version of this bottom one. And they are both the same, they overlap each other, which means then there's infinitely many solutions. And this will always result in a 0 equals 0 true statement. And so from the algebra, that's how you would know if you have infinitely many solutions. So just to clarify really quick here, a false statement is no solution. So that was this case when the lines are parallel, they will never cross. And if we do our algebra and get 0 equals 0, which is a true statement, then that means the functions are perfectly on top of each other, and that there's infinitely many solutions. And so there we have it. Our first video lecture for Math 151. This is section 8.1. It's all about solving these linear equations through the substitution method and the elimination method. And then also, as well, as being able to identify which outcome you're in. If you get one solution, then you simply give that solution. If you get no solution, then that's what you would select. For the MyMathLab, there's going to be an option that you select for no solution. And then they'll also give you another option for infinitely many solutions. So I will talk to you next time.